Imagine a star so massive that our sun looks like a grain of sand next to a mountain. And now imagine that star collapsing so fast it briefly breaks the laws of physics, up to 10,000 times heavier. They lived for just 250,000 years, a heartbeat in cosmic time. And when they died, they didn't explode. They collapsed, straight into the first supermassive black holes. For decades, this was just a crazy idea, until James Webb found their chemical fingerprint. Here's the mystery that's haunted astronomers for 20 years. We see supermassive black holes, some billions of times heavier than the sun, already fully grown when the universe was less than 1 billion years old. That's like opening the history book and finding a 40-year-old billionaire on page 2. How? And the more we looked, the less the universe made sense. Something had to give them an insane head start. And for years, the leading theory sounded like science fiction. The first black holes were seeds from the collapse of mythical monster stars. But without proof, it was just a story. Until now.
So scientists pointed the most powerful telescope ever built, the James Webb Space Telescope, at one of the earliest galaxies we've ever discovered, GS 3073, formed roughly about 1 billion years after the Big Bang. And what JWST saw and cited completely rewrote the rules. Scientists using the James Webb Space Telescope, JWST, have spotted the first evidence of monster stars in the early universe, offering new clues to how supermassive black holes grew so big after only 1 billion years of the universe's history. And here's where things get crazy. Because these weren't normal stars, not even close. What JWST found doesn't fit into anything we've seen before. But to understand why this is such a big deal, we need to look at a strange galaxy hidden deep in the early universe. And this is the moment everything starts to connect. The team spotted these gargantuan stars, each with a mass of between 1,000 and 10,000 times our sun. Yes, you heard that right. 10,000 solar masses, a weight class so extreme we thought it was impossible for a single star. These things make our sun look like a spark next to a volcano. To put that in perspective, the heaviest star alive today is roughly 300 solar masses. These ancient beasts were up to 30 times heavier than anything we thought physics allowed.
The study was co-led by scientists from the Harvard-Smithsonian Center for Astrophysics, CFA, and the University of Portsmouth in the UK, and was published November 12th in Astrophysical Journal Letters. And their lives? Even stranger. Imagine a star so huge it burns out almost the moment it forms. Our latest discovery helped solve a 20-year cosmic mystery, study co-author Daniel Whalen from Portsmouth's Institute of Cosmology and Gravitation said in a statement. These cosmic giants would have burned brilliantly for a brief time before collapsing into massive black holes, leaving behind the chemical signatures we can detect billions of years later. A bit like dinosaurs on Earth, they were enormous and primitive, Whalen added. And they had short lives, living for just 250,000 years, a cosmic blink of an eye.
The research's implications include learning about the first generation of stars, as well as literally shedding light on the cosmic dark ages, or the period of time when the first stars came to light and the chemistry of the universe began to change. And here's the clue that blew astronomers' minds. This is the fingerprint that changes everything. If you only remember one thing from this video, make it this. The stars in GS 3073 had an unusual and extreme imbalance of nitrogen to oxygen, a ratio of 0.46, not usually found in stars or stellar explosions, according to the team. 0.46. Why does this number matter? Because it shouldn't exist, not in any normal star. The signature, however, matched something predicted in models, primordial stars thousands of times more massive than our sun. Study co-author Devesh Nandal, a postdoctoral fellow at the CFA's Institute for Theory and Computation, said. That number is gold, because supercomputer models predicted this exact ratio, but only for primordial stars in an incredibly narrow mass range, 1,000 to 10,000 solar masses. Below 1,000, not enough nitrogen. Above 10,000, totally different chemistry. This is the sweet spot, the smoking gun that says monster stars were here.
So how did these stars produce so much nitrogen? The researchers said it's a 3-step process. Stay with me. This part is worth it. because this is where monster stars reveal their identity. Stars are constantly burning elements in their cores. As these large stars in GS 3073 burned helium, the chemical reactions created carbon. Eventually, carbon began to invade an outside shell of material where hydrogen was burning. In that outside shell, the carbon and hydrogen then mixed to create nitrogen. As the nitrogen was produced, convection currents within the star began to distribute it throughout the star's body. Over time, the nitrogen left the star and flowed into space. In the case of GS 3073, this process lasted millions of years. Imagine the star as a gigantic layered cake from hell. Deep core, helium burning, produces carbon. Carbon leaks upward into the hydrogen-burning shell. Carbon plus hydrogen equals massive nitrogen explosion in chemistry terms. Giant convection currents work like a cosmic blender, mixing nitrogen everywhere. For millions of years, the star literally coughs nitrogen into space. We're seeing that cough 13 billion years later.
The study also found that this nitrogen signature only appears in a specific mass range, the researchers noted. Stars smaller than 1,000 solar masses or larger than 10,000 solar masses don't produce the right chemical pattern for the signature, suggesting a sweet spot for this type of enrichment. And now, the part no one expected, because here comes the twist. This is where everything flips. The big black hole mystery. Based on their models, the researchers further suggested that when these monster stars reach the end of their lives, they don't explode into supernovas. What happens next is instead a big collapse, generating some of the universe's earliest supermassive black holes. No fireworks, no warning, just total gravitational collapse. In a fraction of a second, the entire star falls inward, and a black hole 10,000, 100,000 times the mass of the Sun is born instantly. A perfect seed for the supermassive beasts we see today.
And here's the smoking gun, because what astronomers found next changes everything. Adding more fuel to this idea, GS 3073 does appear to have an actively feeding black hole at its center, potentially the very remnant of one of these supermassive first stars, the statement noted. If confirmed, this would solve two mysteries at once: where the nitrogen came from and how the black hole formed. And here's the cherry on top. Right now, in the heart of GS 3073, there is an actively feeding supermassive black hole. The team believes it could be the direct remnant, the actual corpse, of one of these monster stars. One single discovery just solved two of cosmology's biggest mysteries at once: where all that weird nitrogen came from, and how a giant black hole appeared stupidly early in cosmic history.
The origin of the universe's first supermassive black holes remains one of the biggest mysteries in astrophysics. Some theories suggest they collapsed directly from ultra-dense clouds of gas shortly after the Big Bang and then formed galaxies around them. Other theories point to more exotic explanations, such as dark matter interactions or the collapse of monster stars. But now, thanks to JWST and monster stars, we have a new, very convincing piece of the puzzle. If this is confirmed, we just figured out who ended the cosmic dark ages, who created the first heavy elements outside the Big Bang, who planted the seeds of every supermassive black hole, including Sagittarius A star in our own galaxy. Direct collapse of gas clouds, dark matter-powered stars, primordial black holes from the Big Bang itself, the race isn't over yet.
So here we are, 13 billion years later, reading the last will and testament of the biggest beasts the universe has ever known, written in nitrogen. If that gave you goosebumps, do 3 things right now. Smash the like button. Seriously, it takes half a second and helps push this to millions. Drop your theory in the comments. Best one gets pinned for 24 hours. Subscribe and hit the bell, because in 3-4 days, I'm dropping the follow-up. How these same monster stars powered the brightest objects ever, the first quasars that outshone entire galaxies by a factor of 1,000. You do not want to miss that one. See you in the next one. The universe just got a whole lot scarier. And if this was just the beginning, what comes next will rewrite the whole story of how the cosmos was born.